Hi dear students, let's see this question that came in JEE Advance Paper 2 Physics in the year 2018. The question is fairly simple from the topic of Gauss law. So in this case, there is a non-conducting wire which is infinitely wrong, and the charge density on the wire is lambda. It's a linear charge density. So a section of this wire is being pierced by a sphere of radius r. So basically you can see that this part of the wire is lying inside the sphere of radius r. Okay, and this part of the wire subtends an angle of 120 degree at the center. Okay, permittivity of the free space is epsilon naught. So we have to talk about the flux through this sphere and the nature of the electric field, that means the direction of the electric field on the surface of the sphere due to this wire. So question is fairly simple. We can see that for finding the flux, we can simply use Gauss law. So basically integral E dot ds. Okay, this will be equals to Q enclosed upon epsilon naught. So let's find the charge which is enclosed within the sphere. So this red section of the wire lies inside the sphere, you can see. So if we find the length of this, so it will be, if you draw the perpendicular from this center on this wire, so it will be r sine 60 plus r sine 60. So we can say that Q enclosed will be nothing but lambda into 2r sine 60. Okay, divided by epsilon naught. This will be the flux value. So we can say that it will come out to be sine 60 is root 3 by 2. So we can see it becomes root 3 r lambda upon epsilon naught. So basically option A is wrong and option A is correct and option C is wrong. Now we have to talk about the Z component of electric field is 0 at all points on the surface of the shell. So if you talk about the surface of the shell and see the direction of the electric field, so we already know that direction of the field due to the wire is perpendicular to the wire. If you talk about the infinite wire, then it's in the radial direction outwards. So now if you see this, suppose this is the wire. So at this point, the field will be going in this direction. At this point, field will be going in this direction. At this point, field will be going in this direction. At this point, field will be going in this direction. So basically, you can see that field is always horizontal. Okay, so if you talk about this point, let us say, so it will not have any z component. At this point the field will be in this direction. Okay, at this point the field will be in this direction. At this point the field will be in this direction. Similarly, at this point the field will be in this direction. So you can see it doesn't have any z component. Okay, z axis is taken like in this direction. So there is no z component whatsoever. So option B is correct. Okay, that component of the field is always 0. Electric field is normal to the surface of the shell at all points. This is wrong, because if you see, normal at this point is in this direction. This is the direction of the normal, whereas at this point the electric field will be in this direction. Okay, so you can see that this is not along the normal. If you consider a diameter which is diametric plane, which is which is horizontal kind of, okay, and which contains point O, and which is like this. So on at all these points we can say electric field would have been normal to the surface of the shell. But at the other point, at this point, electric field will be again in this direction, but normal we can say will not be in this direction. So option D is wrong, and hence only two options were correct. But the question was fairly simple, and most of the students would have done it without much hassles. That's it. Thank you.